Confounding and lurking variables. A lurking variable is one for which no data has been collected, but that influences the results anyway. For example, a researcher studies the effect of exercise on blood pressure. What might some lurking variables be? So this researcher has collected data on exercise and is looking to see whether it seems to affect blood pressure. But there are other things that affect blood pressure too. Stress, age, perhaps diet. These things, for which data was not collected but yet affect blood pressure, are called lurking variables. And if they're not taken into account, the researcher might draw the wrong conclusion about whether exercise affects blood pressure. Now, two variables are confounded if their effects can be confused for each other. And a confounding variable is often also a lurking variable. For example, a researcher collects data on beverage consumption and rates of sunburn in Sacramento. He discovers that when beverage consumption rises, so does the rate of sunburn. Now, does this mean that consuming beverages causes sunburn? So if you drink a Coke, you get a little sunburned, and if you drink another Coke, you get more sunburn? Well, no, that's silly. So what's going on here? What might be a confounding variable? So we have beverage consumption. That seems to somehow be linked to rates of sunburn. When one increases, so does the other. But we've said, no, it can't be that the beverage consumption causes the rate of sunburn. That's just silly. So what could be going on here? Well, there's something that's linked to both beverage consumption and rates of sunburn, and that might be warm weather. So when the weather's warm, people tend to need to consume more liquids, but they also tend to be outside, and therefore rates of sunburn would go up. So it's actually the warm weather that's causing the rate of sunburn, and the warm weather just happens to be linked to beverage consumption. So because the thing that causes the sunburn, the warm weather, is linked to beverage consumption, it could appear that it's the beverage consumption causing the rate of sunburn. And that's a confounding variable. Their effects are confounded. Now, in this particular example, it's so silly to think that beverage consumption would cause a sunburn that we can tell there's got to be something else going on here. But sometimes it's harder to tease that out. I'll just mention one other thing. In this particular example, the reason the warm weather and the beverage consumption are linked is that the warm weather causes the beverage consumption, but your confounding variable doesn't have to cause the other independent variable. There just needs to be some sort of linkage of the two, the one that's being studied and the one that's actually causing the effect on the dependent variable. So I've been throwing around this word dependent and independent variable. Let's pin down what exactly I mean by that. In statistics, we're often trying to determine whether one variable depends on another variable, and it's called the dependent variable. The variable we think it might depend on is called the independent variable. For example, in the first Build Your Understanding problem in this section, we considered research about whether sleeping habits affect how well students can concentrate while studying. What were the dependent and independent variables? Well, we were looking at whether sleep habits affect concentration. So we were thinking of concentration depending on sleep habits, which makes concentration the dependent variable and sleep habit the independent variable. In examples 2 and 3 in this section, we looked at an experiment to determine whether receiving treatment, drilling laser holes in the heart, reduced angina. What were the dependent and independent variables? Well, we were looking at whether angina is affected by or is dependent on this treatment of drilling laser holes. So the laser holes are the independent variable and the angina is the dependent variable. By the way, in experiments, the independent variable will always be the treatment. You're always looking to see whether the treatment affects whatever it is that you're studying. One more example. Suppose the researcher in example 5, for some reason, was investigating whether increased beverage consumption causes increased likelihood of sunburn. So, beverage consumption, does it cause increased sunburn? So, the beverage consumption would be the independent variable, and we're looking at whether the sunburn depends on it. So increased sunburn would be the dependent variable.